Yeah, I'm going to explain what I did as experiment, because in my role at Autodesk, it's really about doing experiments on to see where the technology leads us for our customer. And we work, as a 3D package content provider, so we have software for construction, for civil engineering, for manufacturing. And one of the big challenges is for architects, for example, they have this sense of, that's my property, I don't want to share it. So how can they share, for example, a Revit file, which usually is very huge, on the web, and keep the IP for themselves? And we have what we call the Forge technology to do that. I'll very quickly through it, because this is not really the intent of this talk. But it's a very easy way where you take any 3D file format and you export it to JSON information. And then you can start consuming that. So I was using that as a start of developing an experiment. And that experiment was last year, Microsoft released the Hololens. And I was the proud of one of these devices last July. And I say, OK, so the main challenge for this device is really to bring 3D content on it. So why not using Forge for that? And this is what I did, and I want to share my experiment with that. But before going into these details, we need to consider different things. And the first one is, well, sure, you have new devices. Oh, sorry, something wrong on this slide. But you also have new input device. And this new input device could be very, very different. We had in the past only the command line, and we moved to the mouse. And we have other devices where we can see gestures. We had the Kinect on the Xbox. I did some experiment with the Kinect as well to make sure that we can use this, so gestures and full body gestures. So you need to provide input to your device. And lately, we had the natural user interface appearing as a development platform with tablets. So it came in the 2000s. And really, you started with a mouse, right? But now, if you look at all the different opportunities you have to bring inputs on your device, this is what I came out with. Voice recognition, keyboard, mouse, gestures, game controllers, whatsoever. When you build a collaboration service, you need to acknowledge this is as important as what you're displaying, because you are going to collaborate with multiple entities on the same model. So the inputs from the different sources are as important as anything else. So you can categorize them into other things. So computer vision, which is camera reading what you're doing, which is almost what the Kinect is doing. You can do touch on tablets. You have also the audio recognition, so speech recognition or voice recognition. So different gestures you can do. On maybe in future, brain readers. I don't know if any of you were at SIGGRAPH last August, but there was a guy with like an helmet trying to read your brain to do actions on the computer. It was kind of working, but you had to keep a very close focus on what you were doing. So maybe for future. So the first thing I did with a colleague of mine was actually using the Google Tango tablet. And this is what one of my colleagues ended up to, which is combining the 3D digital model with the real world. So this is our One Market San Francisco office. And you see that while it's working, the Tango tablet can connect to the digital model and see him displayed on the tablet. So that's, I would not say geolocation because you're in a building, but the Tango is reading your environment and match that to the digital model. And somewhere in the video, I'll go very quickly through, we just go to 3D world somewhere. Just need to remember where it is. Yeah. So you can also map to 3D world and consume the real 3D data and merge the two together. That's really interesting. So before I go too much in detail, so that's the same video, but this time we moving in 3D. So we consuming the Revit model directly. But before I go into more details about this, I just want to have a feel of how many of you are developers. Couple, designers. Okay. So people who didn't raise the hand, who are you? Yeah, makers, so you do both roles? Anyway, so I'll try to adapt my presentation to the audience. I like this one because this one is very cool, so we can do simulation as well. So you do feature recognition around you, and then using a game engine, you just put water into it, and you do simulation. So you're combining digital and real world together, and you put inside a virtual simulation. This one is most interesting. So here we're starting using a helmet device, like the Hololens. And as I said, I had one since last July to play with it. So this is a virtual visit of a house. And here we're using the tablet to show you how it looks. But we'll do the demo here with the HoloLens in a few minutes. So this is how it looks. And you can walk through the house in your virtual world, and you can really visit the house. So that's a first experiment. But you alone, yeah? It's one person visiting the house. That's great, but that's not yet collaboration. Collaboration would mean that two persons at least share the same model, and they collaborate together on doing change into the model. So that was an experiment we did last year, and it worked pretty well. So here we're using a game engine to do the display, but the information is consumed from any source. So if you have a Revit file or anything else, like Rhino or SketchUp, that's fine. You can do that. And now there was a raise of what I call the new display interface. So you heard about HoloLens because I'm going to talk about that. The MetaVision on the DAQRI Smart Helmet. You can even have a very cheap one, which is a Google Cardboard. So you take only your phone on a piece of cardboard, and you have the same virtual reality experience. So, but before that, just for fun, Autodesk was actually the first doing one of these helmets back in 1993. And at that time, we were really proud to do that. We did abandon that project a year later. But you know, a 4 frame per second device, very heavy on your head. It's very old technology. And Microsoft obviously came up last year with a lot better device. Another device, who heard about the F-35 jet fighter? Nobody? Yeah, one guy? Good. So that's the next generation of jet fighter for the US Army. And that helmet that the pilot is wearing is built by an Israeli company, and it's a full AR/VR device. It's plenty of sensors, and when you wear this device, the jet disappears. Yeah? There's camera all around, and the pilot can just watch around through the steels and glass and everything, and he can see everything around his jet fighter. In a combat, it's very important for them. You obviously don't want to buy this one. 400,000 helmet, I don't think anyone can really afford it. Instead, what you can do for like 20 bucks is to do a Google Cardboard, or if you have a 3D printer, you can print that one. So this is what we are doing before having other devices. So this is how it would look on your phone. So you have a stereoscopic view of the model, and through the glasses you can use it. And now the rise of the augmented reality. So today we'll focus on the Hololens, but you have few others like the Meta and Dacry. And this is how the, if you disassemble it, how it looks like. So you have depth camera, you have real cameras that we're going to use in a few minutes. You have a lot of technology coming from the Kinect, actually. So all the gestures you can use. It has speech recognition, so you can give commands to your model, and you can act on what's doing. So this is what we're going to use here. We only need to be able to speak English today. So it's not like, doesn't support French for me or Croatian for you. So you need to speak English. But the accent is not directly important. Another thing for the HoloLens is you need a Windows machine, Windows 10, and Visual Studio to develop your application. But what means collaboration? So here we are going to use, for this programming experiment, the holographic device, the HoloLens, and we're going to use all these different features from the device. So gaze, which has a cursor. So Microsoft calls that a gaze, but that's a cursor that you're going to move on your model. So gestures, this is how we can select things. Speech recognition, giving other more advanced command. We'll have some special sound so we can orient ourselves in the 3D scene. And the sharing, which will be the base of the collaboration service. So we can share the same model, and the HoloLens has a very clever way of synchronizing devices together, so you can see on the other device what one person is doing. So what means collaboration? And for me, it took me quite a while to really figure out in the industry what people are expecting to do as a collaboration service. Because today, if you ask anyone, what are you doing in terms of collaboration? It's probably like just commenting, right? Commenting is easy. You do that every day with Twitter, Facebook, on Skype. But to be productive in the industry, what kind of other things we can really do in the collaboration service above commenting? So one thing is actually sharing the model itself, but not sharing it like, oh, let me send you the file. Sharing the real model in real time, whether you're having a smart helmet, like the HoloLens, or you're using your phone, or you're using your computer. The notion of device should disappear in a collaboration service. So it doesn't matter anymore which device or technology you're using, that's the experience you're trying to develop. So sharing information, sharing resource, defining roles, and interaction. And interaction is a keyword for me. So I'll pause this one. It's more for developers. So if developers are interested, we can take a quicker look to that. I like this photo. So it's coming from a device provider. But it's really interesting because here, this is where the collaboration starts. So this is a building. And you have information coming or augmented your reality to show you information coming from different things. So here we have a pump at the end of this photo, and you have like an information red icon saying there is a problem, yeah? And then the device, this pump has some sensors on it, or your ERP system has some information to display you, because the device can recognize that pump or find that pump in the scene, then you can bring automatically information. And that information could be coming from your data center or from one of your colleagues. So the use case here usually is you have a technician who needs to go to repair something, but he got the information from someone who detected that the device had an issue. So this is how you combine information together. And you can talk to the guy can collect information, he can query more documentation, he can say to your ERP system that the problem is fixed. That's really an interesting use case. So in that regard, this is the experiment we did, which was, okay, so we have on Pier 9 in San Francisco again, an office where we have CNC machine. So we put sensors on the CNC machine to measure how much they used, what kind of usage people are doing with that. And we did build a website where we can collect information and show with coloring what people are doing with that. So that's the IoT part. And then you have the tablet, which can display information on top of the real world, and you can read that information. We also have the Hololens now connected, so if you walk into this room, you can see that. But because now we have 3 different entry points, people can start sharing the same information or giving orders to each other or doing anything you want. Another experiment we did using another technology called VRED was actually for car designer in the automotive industry. So they can change the shapes, they can change the material of different cars, and they can discuss as a team what the car should be at the end, what kind of configuration are acceptable for this car to be released on the market. So that was this one, where you can see that people can draft curves on the car to define what they want, where they want to put stickers on other things. But my colleagues, so that was the car they were working on, but my colleagues were in an empty room. And here you have 2 persons in the same room, but there was 2 other persons in another room, and they were working together on defining what should be the right setup for that car. So that, we passed that product things, you're probably not interested. What is interesting as well is there's 3 kind of device. You have tablets. So the issue with tablets is they are in your hands. You can't really do anything while you have the tablet in your hand. The next one, which is very popular right now, is what we call virtual reality, which is like on the screen. So HTC Vive or the Google Cardboard, etc., Oculus Rift. The problem with that is you are in a pure virtual reality mode, which means you can't really interact anymore with your real world. So if I were wearing the HTC Vive, if nobody stopped me, I can just follow out the scene and hurt myself because I'm fully immersed into that virtual world. So how do you interact with the real world now? Using a keyboard, you can't see the keyboard, so it's very difficult here. But the experience is good because you only see what you need to see, and you focus on that. On one difficult thing is, how do I move to another place in the virtual world because I know I can't fall here. It's like you can use teleportation. So, and this is what we did, which is you say, I want to move there, and suddenly you're on the opposite side of the room. What I want to tell you here is that in this world, you need to invent all the different user interaction you want to have for a specific experience. So you can use different things like menu, teleportation, voice control, etc. So you have to define your way of navigating into a virtual world. Whereas when you, let's play this one while I talk. Whereas in the augmented reality world, you not only constrained to do teleportation, you can interact now with the real world. And that's, I think, even more important. So in the construction industry, what people usually want to see is I'm in a room, there is a ceiling, and I want to see what I can't really see in the real world, but I want to see where they're positioned relative to my real world. So this is really what they're interested by. So here, what we were doing as an experiment is a fire escape on an oil platform. So we did combine that with a game engine, but you could play a role yourself into it. So you could be inside the scene and see how people represented here by yellow bars, how they react on which path they're taking. So you can see, like, for example, this guy here is just stuck. He won't move anymore. So there's an issue in your simulation. So the first stage before we can go to the experience is how do you bring that content into all these devices? Someone here may use SketchUp, another one may use Rhino, a third one may use Revit. If for each of you, you need to find your workflow to bring this content to one specific device, it will be a lot of work. I know that one of the customers I met one day was not happy me saying, usually it takes you like a week work to bring a simple thing into one of these devices. But that's true. If you really want to have a very nice and very clear material definition into your device, you usually need to hire an artist. He will play for a week on your model to bring it. Another way is to use a different pipeline. So that was a pipeline I mentioned at the beginning, like Forge, where you could put anything there, and at the end, it's just JSON. So you would consume anything you want, because it's now a database, and you just need to build a piece of code to bring that 3D content to your device. And this is what I did. And like, I think the first presenter this morning, Christian, was saying, anything I do is public and I share it. It's exactly the same for me. I think his talk was great, saying that you need to combine things together, which are public, don't be afraid of that, and build something, and then share it. So if you're interested to see that, I'll give you the URL where you can get it. So here, this is what we're doing. We were building from all these 3D package content that you can reuse very easily, because it's now a database. Another way to do it is actually to do laser scanning or photogrammetry scanning. So laser scanning is pretty expensive. I think the device is like a $15,000 the device to scan a room or a building. And you get a point cloud, and we can convert that into a mesh. And since it's a mesh, now you can consume it. Another way is to use your iPhone and take photos of objects, and from this photo, you can rebuild the mesh itself. So there's different way of importing content. So model preparation is very hard. This is where you're going to spend a lot of time. And if I use Forge, I don't need to worry about that anymore, because I would use all this information directly from a database. So we have derivative information, which is geometry on material, the properties, which are all the information contained in the original file, and we also have the hierarchy, so we can do funny things. So we will do that an experiment. So this is what I'm going to show you right now. And actually, it's hard for me to talk while I am doing the demo, so is there anyone who speaks English and want to help me and come on stage and wear the device so I can talk? Yeah, just come. Just need to start it, yeah. Trying to map. I need to close this. Okay, so there is a menu, which will be in front of you, so let me adjust. So remember, there will be a few seconds delay between what you see and what people see. Mm-hmm. So we'll try that. So on the menu, you should see a blue square at the bottom right. So if you move your cursor, and now you click. Yeah, you need to keep the cursor here. Yeah, that's a click. Let me do it for you. Just watch this, and are you not? You're not on it. Yeah. And now what? I need to do it one more time. Yeah, and it will load. So this example is actually a robot arm, and we're going to play with it a bit. So yeah, it appears. So this is what you can see. Let me put it full screen so everyone can really see it. So that's a robot, and actually we can interact with it. So in this demo, if I had more Hololens on stage, we could have multiple persons playing with the same robot. And because the Hololens has microphone and special sound, we can talk to each other directly, even if we're not in the same room. So what you're going to do now is to click on the robot somewhere, like here. Yeah? No? Try again? Yeah. And it just animated the robot. So now, yeah, you can work around. So now you have the robot moving. So imagine that you control the robot remotely. Yeah? Wouldn't it be nice? You control the machine. I think Christian this morning was saying the machine control you. Now you control the machine. And you can play. Can you say smaller? Just say smaller. Smaller. No, smaller. Small. No? Try again. Smaller. Yeah? Again. Yeah, so cute. Or bigger? Make it very big, like say bigger, like 3-4 times. Bigger. It will become a giant robot. It will go off the roof. Again. Okay. Yeah. So we'll stop this demo here, but you understand now if you connected with multiple people, you can start interaction, you can start playing, you can... If this demo had commands to change material or change the model, we could. So this demo doesn't have. So let me do a gesture for you. Yeah, watch here. There should be something. Yeah. Can you put the cursor on the top right corner where it says close or, yeah, undo the gesture? You should close the window. Yeah. So I'll do again this. You should have a menu in front of you. No? Yeah. There it is. So can you select now the black one? Yeah. Click on it. And wait a few seconds. So now we're moving to the manufacturing world. So this is a piece of whatever. It's a crane hook. But this time, I'm not sure if you can see, but can you see the little reddish tooltip which follows the cursor? No, you can't really see it. So just imagine there is one. You should be able to read it on the device. So this is what we call metadata. This is information we extract from the digital model. And you can query any of this metadata. So while you see the model, you can say, what's your volume? Or what's your area? What's your whatever? What's your model? On this crane hook, actually, you can say, can you say explode? Yeah. Remember, there is a slight delay between what he sees and what we see because of the connection here. Because we have this hierarchical information from the original model, we still know how things are assembled together. So we can explode the model. And just for fun, my director, when I show him this demo, was in a plane, right? And he was saying, explode! All his neighborhood was like, what's this guy doing? Yeah? Can you say explode in a plane? I was like, come on. Anyway, can you say combine? So it will bring back the... And now the model should be reassembled. And if you click on something which is not red, and you say select, yeah, anything not red. Yeah, I'm a poor programmer. I just made the selection red. So if it's red, you can't see it. Anything. Just say, no, say select. Yeah, so you can see on the white axis that you have a reddish line surrounding the object. So now you can select object and you can move them, you can put them anywhere. So you can now interact with the model. So watch me and say menu. Menu. So you should see two images now. Can you go on the house and say load? So now we're going to move to the construction world with a house. And now we have a house. So make it very big, because I think what is interesting is you can do a visit of the house. So you can say bigger. A bit more. One more. Yeah. Okay, go in now. Just walk in. And show the kitchen to people. Yeah, basic wall, okay. Where's the kitchen? In your back. That's the salon. That's the entrance. Stairways. Yeah, right. Watch your step. Yeah, here is a kitchen. So you see now you can kind of do a visit. Try to find the restrooms. The restrooms. Just try to walk and try to find it while I talk. So now we saw that in manufacturing we can interact with objects. Now this guy can just visit a house, and we have a big stage so he can move around. It's near bedroom if it helps. So you can almost do anything you want. And what is nice now is if you two people visiting the same house, you can get avatars moving around you. Or you can have an assistant telling you what this is, or you can ask questions. Because if now you combine machine learning, you can talk to the machine, and the machine can tell you what you're interested by, or how things are made, or whatsoever. Isn't it cool? Nobody want to try? So we're a sponsor for this event, so we have a table. If you want to try all these experiments, you're welcome to go to our table. We have Hololens where you can try things. Yeah? Good. Thank you for your help. I think it's worth for the demo. Okay, so just to finish what I was doing, do you have any questions? So all the code, again, is public. It's also published on the blog, and I'm happy to answer any questions you have if you want to use that code for your own purpose. Yeah, there was a question?
So a few times, me and my colleagues use Oculus, and we noticed that we got like huge headaches from using the actual device. I guess we got like sensory overload load or something like that. Did you actually had to accommodate for that, or did other users also got it?
So with the Hololens, on even more with the Dacry Smart Helmet, the Dacry Smart Helmet is bigger. You'll get also headaches, but not for the same reason. It's because it's heavy. So it's like you put like 1 kilogram on your head on the whole day, and you like, yeah, okay. So the motion sickness you're talking about, you won't get that with any of these devices because you're still in your real world. So even if you see holograms, you still see your real world, so your eyes and your brain still connect to your world. So whatever happens, you won't get that. But if you wear, let's say if you wear the HoloLens 8 day long, it's like you're having an helmet all day long. So if you're used to that, no issue. If you're like me, like wearing it like maybe 20 minutes maximum per day, but one day you start 3 hours, yeah, it's like, so you're like, it hurts a bit. It's a physical thing this time because it's quite heavy. So I know all of them, they're working on having like all the hardware here on just the holographic display here, which will make that very, very light. But yeah, that's an issue today.